Morning, everyone. Welcome back to another exciting day in mathematics. How's everybody doing? Good? Yeah? Yeah, there's that door. Warm-up number 22 is on the screen. There's a couple of new things that I have in there, but I think everything's doable. Maybe the last one I might need to go over. But other than that, the rest of it is just extra practice. See how you do with that. Give you some time. Copy and go. All right, let's get this show on the road. Number one. Number one is a straight multiplication, binomial times binomial, yes? All right, William, go. What'd you get? Negative 10i squared minus what? 29i plus 21. This middle term is incorrect. Double check with your neighbor, see what you got for that middle term, please. Right? Should have gotten what? Negative I, just an I. Negative I, or 1I. All right? Now, before we go any further, I'm going to start giving you extra practice for these kinds, okay? Write your utensils down, look up to the screen really quick. Check this out. This should ring a bell, the I's, right? Yes, Mr. Q, we covered this at the beginning of the school year. Yes, I introduced what kind of number? Imaginary numbers, yes? And we said that an imaginary number, or the I, is the same as square root of negative 1. Are we there so far? Okay. However, from this point forward, check this out, I'm going to manipulate this to get rid of the square root. Focus, please. Put away those cell phones. I'm going to take them away. How do we get rid of this square root? By taking a square. Whatever we do to one side, we do to the other side. So that means that I squared is the same as negative 1. Make a note for yourself on the side. Write this down. I squared is negative 1. I squared is negative 1. Which means, basically, that we are not done with this anymore. Because now I can do this. Negative 10, and instead of I squared, what am I going to substitute in there? Negative 1, that is correct. Negative 1 because of this. Bring down the negative I plus 21. So, question. What is negative 10 times negative 1? 10 minus I plus 21. Can I combine like terms? Yes. What is 10 plus 21? This is 31, and then at the end we write minus I. Copy that. Now, you're saying, but that's not in standard form, Mr. Q. I know. The only time that we write the I at the end, or the variable at the end, is when we have a complex number. Now, I'm going to be giving you some practice, because we're about to get into complex and imaginaries coming next week and the following week, okay? But I'm going to be dropping this practice here right now. Okay. Thank you, Mr. Q. All right, number 2. William, pass someone. Andrew. Number 2. Huh? Yeah, I'll come back to you. Number 3. Andrew, pass someone. Samuel, what'd you get for number 3? X plus 4. X plus 5. Tell your neighbor what's the only thing that Sammy forgot at the end. Yeah, the BFF, which is 3, because that's the GCS that we take out at the beginning. So don't forget to bring that down at the end. Thank you, Samuel. Number 4. Pass someone, Samuel. Nayeli, what'd you get for number 4? X squared X plus 3, okay. Oh, okay, so we grouped x squared for this, and we're left with x plus 3. What's GCF for these two? -1. We're left with x plus 3. So my factors are x squared minus 1. And then what is the other one? X plus 3. Yes? Did everybody forget how to factor by group? Some of you? Okay. However, you guys do like all the memorization of the identities, right? You're like, oh yes, Mr. Q. Oh, I see, Mr. Q. This is a minus and a square. So that looks like what? X squared minus y squared. Is that correct? So that becomes what? X plus y, x minus y. Which means this is what? Square root of the first, square root of the last, one positive, one negative, and bring down the x plus 3, and these are my factors. Make a note for yourself that this is a difference of squares. Difference of squares. All right. So let's see. Number 2, Andrew. Okay, close. So when we distribute this negative here, that becomes negative 7x squared plus x minus 3, and then we combine. That leaves us with 3x squared, and it's a negative. Then we got minus 2x, and then at the end, minus 3. And if you got that, okay, some of us. All right. And last but not least, notice that I'm bringing in here also, check this out, a two-variable equation. Because we're about to be done with polynomials, guys, and we're about to head into some functions and also some imaginary and complex numbers. So I'm just going to start giving you practice from now on. So like that, when we get there, you're going to be, oh, I got this. All right, so it says solve for x. Line down the equal sign. I need to leave x by itself, so I need to get rid of the 8y. So what do? Minus 8y minus 8y. We're left with negative 2x equals negative 8y plus 16. Is the x still by itself? No, there's a negative 2 multiplying, so that means we need to divide by negative 2, divide by negative 2. We're left with x equals, what is negative 8y divided by negative 2? Positive 4y. What is 16 divided by negative 2? Negative 8. Woo! Let's go. So yeah, we're about to get into two-variable equations. Notice that at the beginning of the school year, we did a review for Algebra 1. We only got to one-variable equations, right? We did a bunch of stuff with that. So there you go. I'm bringing these in, okay, little by little. All right, copy the agenda for today. Here we go. Warm-up number 22 is done. Factoring polynomials, we're still on that. And we're about to get into division. Yay. Some of you love division, right, from ever since elementary, yeah. And tonight's home play is only 2 pages, 316 and 317. It's only 18 problems, only. But since you're only going to do odds, that means it's half of that. Okay? After that, get a Cornell note ready, please. You don't need a Ferri model. We're showing polynomials. again, your home plate for tonight, 316, 317, odds only. Okay? All right? Our objective for today, I can factor polynomials. I'll give you some time to set up your Cornell note, and then we'll get started from there. Okay, all ready? Let's go. This part is like really very smooth once you like see it, but to get there, it's the challenging part. All right? I can factor polynomials. So where have we been? Do we know what polynomials are by now? Yes, tell your neighbor the definition of polynomials, please. So you're like, I don't remember. Really? We've been on this for 2 weeks already. They're monomials or somewhere different than monomials. Bah. And then we did some GCF, yes? Then we did binomials, trinomials, then with GCF, and then trinomials with negatives, more negatives, more negatives. Then without a GCF, then we needed to multiply the leading coefficient times the constant, and so on and so forth. We got to these, and then finally we got to this kind. Okay, and what is this kind called? This difference of squares. Now, yesterday I left you guys a video lesson. Hopefully you took copious notes, yes? And they talked about the polynomial identities, right? And that we were going to add more to those. So therefore, check this out. You needed to copy x cubed minus y cubed and x cubed plus y cubed. These two will have a particular name. This is difference of cubes. This is sum of cubes, yes? And then that means that this became that, and this became that. So I want you to copy these last two again, please. We're going to need those for today, the last two only. X cubed minus y cubed, that becomes this, and x cubed plus y cubed, that becomes that. Copy it again, please. Give you some time. So, before I get to that, turn your notebook over really quick. Yes? Okay, turn it over. All right. So by now, we should know what this is. Is that correct? Tell your neighbor what the name of that one, please. Yeah, difference of squares. So if I was to ask you for the factors of this one by memory, since it was one of the identities, tell your neighbor the factors for that one, please. What are the factors? Very good. X plus y, x minus y. Right? Okay. Now, this is very fresh because this is part of the video you saw yesterday. Is that correct? So today, we have x cubed minus y cubed. Let me show you an easy way of memorizing the factors of this one. First, you write everything but without the exponent. So we write x minus y. The other factor, you start with x squared plus xy plus y squared. And you're not copying this, you're just paying attention. Look at this one. X cubed plus y cubed. How do you write this one? Well, you start writing everything the same except the exponents, x plus y. Then you write exactly what we have here, but the middle term is a minus. And everything else squared. All right? Here it goes again. X cubed plus y cubed. Without looking at your notes, tell your neighbor how to start that one, please. How do we start that one? Elijah, how do we start that one? x plus y. That's how we started, right? Exactly the same, but without the exponents. So what's the second part? The second part is a trinomial, x squared minus xy plus y squared. Okay? So, tell your neighbor, x cubed minus y cubed. How to start that one, and then give them the trinomial after that. All right. Addison, go. X minus y. What's a trinomial? Savannah. X squared. Close. Plus xy plus y squared. Okay. All right, here it goes again. Look at this one. Difference of squares. Tell your neighbor what to write over here if I was to ask you for that. That becomes what? Dana, go. X plus y. X minus y. Hands if you thought that, yes? Okay, not bad. All right, look at this one. X cubed minus y cubed. Tell your neighbor how to write that, please, without looking at your notes. All right, Clarissa, go. X minus y in the trinomial. That is correct. Let's go. How about this one? X squared minus y squared. Tell your neighbor what that becomes again, please. Amber, go. X minus y. No, this is a squared. So therefore, x minus y, x plus y, or x plus y, x minus y. Okay? One more. X cubed plus y cubed. So you know what to write, please, if you were to write that without looking at your notes. All right. Diego, go. X plus y. X squared. Minus xy plus y squared. Okay? Guys, you need to know this because we're going to get into the next problems. It's going to go pretty quick. Okay? All right. I'll leave those aside for right now. Back to this one really quick. If I was to give you a square and the area of the square is 16, and I wanted to ask you where I got the 16 or where it came from, that's why we need to look at its roots. That's why we take a square root. So to find out where 16 came from, we take the square root. That means what number times itself? 2 times give us 16. The answer is what? 4. Okay. With cubes, it's the same idea. If I give you a cube, now it's a 3-dimension. So that means if I was to give you the number 27 as the volume of the cube, so what do I need to do? Not square root. Now I do cube root to find out where 27 came from. So that means what number times itself 3 times give us 27. So what is that number? 3. 3 times 3 is 9 times 3, 27. So keep that in mind because we're going to be working a lot with cubes right now, and you're going to have to be thinking about that in regards to multiplying times itself 3 times. So with that said, copy this. Example 1, factor completely, negative 3x to the 4th plus 24x. Negative 3x to the 4th plus 24x. All right. Like any factor, you tell your neighbor the first 2 things you're going to check for, please. First 2 things. Good conversations. Yeah. Is it in standard form, everyone? Yes, from highest to lowest degree. Does it have a GCF? One number divides the first and the second. I hear 3, but this one has a negative, so it's negative 3. Okay. What else do both terms have in common? 1x, so that leaves us with 3x to the 4th divided by negative 3x, that's positive x cubed. 24x divided by negative 3x, that is negative 8. All right? So, writing utensils down, look up to the screen. I'm going to take it from here so you can see it. But please stay focused or you're going to miss it. Here it goes. So, red flags. It's a binomial and it's a minus, and this one is a cube. Okay. So in my mind, I know about difference of squares, but now this kind of looks like difference of cubes. Let's find out if it's true. Can I take the cube root of this one? Yeah, that'll be x, or I can rewrite that as x to the 3rd. Okay. Can I take the cube root of 8? Yeah, one number times itself 3 times gives us 8. 2 times 2 is 4 times 2 is 8. So that means I can write that as 2 to the 3rd power. Is that correct? Yes? Okay, before you copy, check this out. So that means that I do have a difference of cubes. So before you copy, this looks like an identity that we have in our memory already, right? X cubed minus y cubed. What would that become? Talk it over your neighbor without looking at your notes. Yeah, very good. X minus y times x squared plus xy plus y squared. Copy that really quick. I'll give you some time, and then we'll finish it up together. All right, here we go. Writing utensils down, look up to the screen. So, do you agree that this is a difference of cubes? Yes, Mr. Q, this looks the same as this. Yeah, that is true. So if that's true, then that means that my factors for this one should look like this. Is that correct? So I'm going to write them out, exactly what I have here. X minus y, then I got x squared plus xy plus y squared. Before you copy though, look up. So we have let's see, here instead of x, we still have an x, so that means here I'm going to use x, okay. Here we have a y, what do we have here instead of y? 2, so I'm going to write that here, which means I'm going to substitute these 2 all the way through. So that means for x, it's still x. And that means for y, I'm going to use the number 2. Which means, check this out, at the end I should end up with x minus 2, parentheses, x squared, plus, what is 2 times x? 2x, plus, what is 2 squared? 4, and these are my factors. However, look up, don't forget who? Our BFF, negative 3x. Copy that, please. All right, so far so good. From 1 to 5, how comfortable are you with these so far? Got some fours. Okay, we're getting there. So here goes again. Let's go through the process. It's a polynomial, so we check for standard form. Was it in standard form? Yes. Second thing we check for is GCF, which was negative 3x. From there, we end up with this binomial, and what was the red flag? That it was a minus, and this was a cube. So to check if both of these were cubed, we take the cube root of each of the terms, and we rewrite it to the third power. Then that will remind us of our identity. We wrote our identity over here, and then all we have to do is match each of the variables to whatever the term we have here and simplify at the end, okay? And also don't forget the BFF. So let's do another one. Let's do it together. Here we go. Example 2. Copy this. 2x cubed minus 54. 2x cubed minus 54. All right. So what do we check for? Standard form. Is it in standard form? Yes. What's the second thing we check for? GCF. Is there a GCF? Yes, which is 2, and we're left with x cubed minus 27. Okay. Next, red flags. That it's a minus and it's a cube. So let's check to see if both of them are cubes. Can we take the cube root of the first term? Yes, that would be x, and that we write it to the third power. Can we take the cube root of 27? Yeah, that is what? 3 to the third power. So that means we do have a difference of cubes. So let's write our identity. What's our identity for cubes? X cubed minus y cubed, which becomes what? X minus y, x squared plus xy plus y squared. So we do a double check. Does this look like this? Yes, Mr. Q. So let's see. This is our x. We still have an x. But instead of y, what are we going to substitute? Bless you. The 3. So let's write our two factors. My factors are x minus y, bless you, x squared plus xy plus y squared. There we go. This is x, x, x. And instead of y, I'm going to use what? 3, 3, 3. All right, let's simplify. X minus 3, x squared, what else? 3x plus 9. And these are my factors. But don't forget who? Our BFF, which is the GCF. So how many factors do we have? 1, 2, and 3. Woo! Let's go. From 1 to 5, how comfortable are you with this? 5 fours, 5 fours. Okay. Let's do another one. Copy this one, please. Example 3. We got 16a cubed x minus 54b cubed x. All right. Is it in standard form? Yes. Is there a GCF? Yes. Talk it over here. Let me know what the GCF would be for this one. What would be the GCF? One number divides a number, and what else do they have in common? Looks like Nayeli's got this. Very good. Andrea's got this. All right. Help us out, Jaden. What was your GCF? What number divides 16 that divides 54? Not quite. Ayalani? She said 2. Hands, have you got 2? Yeah. What else do they have in common? Each have a what? X. That is correct. So my GCF is 2x. So 16 divided by 2 is 8. We got the x out. That leaves us with a cubed. Minus 54 divided by 2, that's what? What? 27, yes. Make some space there. Yeah. 27. We took out the x. That leaves us with the cubed. That looks familiar, doesn't it? What's the red flag? The minus. Both of them are cubes, but except the numbers, we need to rewrite them as well, right? So, here we go. Can we take the cube root of this one? Tell your neighbor how to rewrite that as a cube. What's another way of writing that, Victor? 2 to the third power and a to the third power, which is what? 2a to the third power, yes. How about this one? Let's check this one. Can we take the cube root of that? Yes. Tell your neighbor how to write that as a cube. Alexa Hernandez, how do we write that? 3b cubed. Hands, have you got that? Yeah, that is correct. And it's a minus, so it looks like we do have a difference of cubes. So that means our identity that we're going to use is what? X cubed minus y cubed, which is x minus y, x squared plus xy plus y squared. So, this is a little bit different, but it looks just about the same. Does this look like that? Yes, okay. So that means we're going to write our factors. We got x minus y, x squared, plus xy, plus y squared. However, instead of x, what am I going to use, everyone? 2a, that is correct. And instead of y, what are we going to use, guys? 3b. So, let's substitute all that throughout. This is 2a, and then the other one is 3b. Then we simplify. Here we go. So, we write 2a plus, minus, my bad, minus 3b times. What do I write next? What is 2a squared? 4a squared, that is correct. What is 2a times 3b? 6ab, yes. Plus, what is 3b squared? 9b squared. These are my factors. Am I done? No, don't forget the BFF. Bring down the 2x. So now we have 1, 2, 3 factors. Woo! Are we doing? Yes? Yes, Mr. Q, we got these. All right, good. So that's the home plate. Just that. All right, here goes another one. Copy this one. Example 4. 27a cubed plus 8. 27a cubed plus 8. when it gets stuck. All right? Standard form? Yes. Is there a GCF? No. Okay. But what is a red flag here, guys? That it's a cubic, right? And here we have a positive. We do have an identity with cubes and a positive, but let's double check. Can we take the cube root of that and tell your neighbor how to rewrite that, please? How do we rewrite that, Ayalani? Parentheses what? What number times itself 3 times gave us 27? 3, and what number times itself gives us a cubed? A, so this can be written as 3a to the 3rd power. Okay. How about this one? What is cube root of 8? 2. That is correct. So we can write that as, cubed. Cubed. But this is a what? A sum. All right, which means it's this. Look up. X cubed plus y cubed. Tell your neighbor without looking at your notes the 2 factors that becomes. What are our 2 factors? William's got this. Go, William. Parentheses. Without looking at your notes. There you go. X plus y. Let's go. Yes. So that means if this looks like that, so that means we're going to use these 2. We got x plus y and x squared minus xy plus y squared. However, instead of x, what do I use? 3a. And instead of y, we use 2. So we substitute all the way through. This is 3a squared. This is 3a. And for the y, we got 2. 2. All right, so that means this becomes 3a plus 2 times 9a squared minus 6a plus 4. These are my factors. Wait, do we have a GCF? No. So these are factors. Whew, man, let's go. From 1 to 5, how come you're ready with these? Yeah? 5, 5, 5, 5. Okay. All right, I'm going to give you one for you to do by yourself. Yes? Yes, thank you, Mr. Q. You're welcome. Yeah, I got you. Number 5, 125x cubed plus 1. I'll give you some time for that. Copy and go. If you have any questions, ask William. He's got this. Should be done by now. They're factors. Here goes the process one more time, just in case you're still having issues with this one. Cube root of 125x cubed was 5x to the 3rd. Is that correct? From there, cube root of 1 is 1. And that's a sum. So that means when we use our identities, we got x plus y, x squared minus xy plus y squared. So instead of x, I'm going to write what? 5x, 5x squared, 5x. And instead of y, I'm going to write what? 1, 1, 1 squared. So that means my factors are 5x plus 1, 25x squared minus 5x plus 1. And these are my factors. Hands, have you got that? Yeah, we got this, right? So once again, your home plate for tonight is pages 316, 317, odds only. Once again, if you have questions, I'll be here after school for tutoring. Other than that, I think we got this, yeah? Yes, Mr. Q, thank you. You're welcome. And we're back to our regular scheduled program. And by the way, make sure you do your practice because I'm not doing an extra day with this. We got to move on. So tomorrow we're going to move on to division. Let's go. Division of polynomials. Thank you, Mr. Q. I'll stop the video right there.